Excellent job. Now we are going to learn about interior angles theorems. These are theorems that deal with the angles in between the parallel lines.
Let's take a look at this. Are there any relationships that we can see, also? Yes, corresponding angles, we have the vertical angles, but is there anything else that we can see in there that might be a shortcut? We have a lot of things going on here, so let's talk about them. So the first one is going to be alternate interior angles theorem. If a transversal intersects two parallel lines, then the alternate angles are congruent. So 5 and 3 are alternate interior angles, and since those lines are parallel, angle 5 is going to be congruent to angle 3. Likewise, angle 4 is going to be congruent to angle 6. Okay? Alright, here's another one. Same side interior angles. If a transversal intersects two parallel lines, and same side interior angles are supplementary. So, same side, 4 and 5 are same side. So what it says is that the measure of angle 4 plus the measure of angle 5, it's supplementary, meaning how many degrees supplementary? 180. Likewise, 3 and 6. So the measure of angle 3 plus the measure of angle 6 equals 180. Which is nice because now if I knew angle 4, I could plug in what the measure of angle 4 is, subtract it from 180, and find out what I have.
Okay, now that you know these theorems, let's prove the alternate interior angles theorem. In order to set everything up, we need to know our hypothesis. That is what we are given. We also need to know our conclusion, because that is what we are trying to prove. Of course, we're going to want to see a figure to see how all of this works. So let's take a look at our picture here. Now that we have a figure, we can actually make a statement using our figure. We know that lines A and B are parallel, and we should probably also add that D is a transversal. And we can see that angles 3 and angle 6 are alternate interior angles, so we need to prove that they are congruent. So how are we going to go about doing this? The only thing that we know about parallel lines and their angles right now is that corresponding angles are congruent. So what I'm going to do is I'm going to throw into this figure a number on one of the corresponding angles. So let's get busy. Obviously, a good place to start is with the given. So A is parallel to B, and D is the transversal. But now, since we know that A is parallel to B, we also know something very interesting about this figure, and that deals with the corresponding angles. We know that angle 2 is congruent to angle 6 by the corresponding angles postulate. Do you like my abbreviation there, CAP? Now obviously that's not enough to say that angle 3 and 6 are congruent, but somehow we do need to get angle 3 in here. What do you notice about angle 3 and angle 2? Hoping that you notice that they are vertical angles. So by the vertical angles theorem, we know that angle 3 is congruent to angle 2. Oh, are you seeing what I'm seeing here? I'm seeing that A is congruent to B, and B is congruent to C. Those are three different terms here. So what does it sound like we are going to be using? Probably the transitive property. Which transitive property? Well, we are using congruence. So that would be the transitive property of congruence says that angle 3 is congruent to angle 6. So that was a quick and easy proof there. Okay, now let's look at some angles that don't fall under one of our theorems. Given that line A is parallel to line B and line D is a transversal, let's prove that angle 1 and angle 8 are supplementary. This is probably going to be a little bit trickier. A good place to start is always with the given. So line A is parallel to line B and D is a transversal. Well, so far we have three postulates or theorems to use. We have the corresponding angles postulate, we have the alternate interior angles theorem, and we also have the same side interior angles theorem. So let's look at the figure and see what's marked. I don't see alternate interior angles. That would be 5, and this angle here that's not marked. So I don't think that we want to be using the alternate interior angles theorem. Same side interior angles theorem would require this angle and number 5. So it also looks like we're not going to be using the same side interior angles theorem. So that leaves the corresponding angles postulate. Let's see, angle 1 and angle 5 happen to be corresponding angles. So what can we say about angle 1 and angle 5 using the corresponding angles postulate? Well, that postulate says that if lines are parallel, then the corresponding angles are congruent. Somehow we still need to get angle 8 in here, and I do notice something right here, and that is that angle 5 and angle 8 create a linear pair. And if they are a linear pair, the linear pair property says that the measure of angle 5 plus the measure of angle 8 is equal to 180 degrees. I'm going to kind of take a step back to 2 here, probably something that I should have said before. If angles are congruent, that means their measures are equal, and that is the definition of congruent angles. And now that we know that the measure of angle 1 is equal to the measure of angle 5, the substitution property of equality allows me to swap out the measure of angle 5 for the measure of angle 1. So I can now say the measure of angle 1 plus the measure of angle 8 is equal to 180 degrees. And once again, that was the substitution property of equality. I think we are pretty much done here, because if two angles measures total to 180 degrees, that says that they are supplementary by the definition of supplementary angles. So that means that angle 1 and angle 8 are supplementary.